The carbon cycle is a complex series of processes through which all of the carbon atoms in existence rotate. The first step of carbon cycle is when carbon enters the atmosphere as a carbon dioxide from respiration and combustion. The second step is when carbon dioxide is absorbed by producers to make carbohydrates in photosynthesis. The third step is when animals feed on the plant, passing the carbon compounds along the food chain. The fourth step is when the dead organisms are eaten by decomposers and the carbon in their bodies is returned to the atmosphere as carbon dioxide.
The carbon cycle involves two different biological reactions, photosynthesis and respiration. Photosynthesis is a process in which the plants convert light into glucose. Here we have the skeleton equation of photosynthesis. As you can see, you need carbon dioxide, water, and sunlight to produce glucose and oxygen. Since it needs sunlight, it's an endothermic reaction. Respiration, it's the inverse reaction. It needs oxygen and a carbohydrate to produce water, carbon dioxide, and it releases energy. So it's an exothermic reaction. This can also be like combustion or metabolism.
The concentration of carbon dioxide in Earth's atmosphere had reached 391 parts per million in October of 2012 and rose by 200 parts per million during 2000 and 2009. This current concentration is substantially higher than the 280 parts per million concentration present in pre-industrial times, with the increase largely attributed to the anthropogenic sources. Carbon dioxide is used in photosynthesis and is also a prominent greenhouse gas. Despite its relatively small overall concentration in the atmosphere, CO2 is an important component of Earth's atmosphere because it absorbs and emits infrared radiation. The natural sources of atmospheric carbon dioxide include volcanic outgassing, the combustion of organic matter, wildfires, and the respiration of processes of living aerobic organisms. Man-made sources of carbon dioxide include the burning of fossil fuels for heating, power generation, and transport, as well as some industrial processes such as cement making. It is also produced by various microorganisms from fermentation and cellular respiration.
The concentration of carbon dioxide in Earth's atmosphere has reached 391 parts per million as of October 2012 and rose by 2 parts per million per year during 2000 to 2009. This current concentration is substantially higher than the 280 parts per million concentration present in pre-industrial times. Carbon dioxide has unique long-term effects on the climate change that are largely irreversible for 1,000 years after emissions stop. Even if human carbon dioxide emission were to completely cease, atmospheric temperatures are not expected to decrease significantly in the short term.
The main chemical equations involved in global warming would be the creation of carbon dioxide. That would be formaldehyde plus oxygen react to create carbon dioxide plus water plus energy. And the global warming is also affected by photosynthesis, and that would be carbon dioxide plus water plus energy will react to create formaldehyde plus oxygen.
Our conclusion is that throughout this investigation, we could learn many new things about carbon, its cycle, its reactions, and its formulas. It also causes increasing effects on the atmosphere, and we need to stop combustion to solve global warming. We hope you enjoy it and thank you very much.